Hey, this is Jan, and in this video we're gonna set up a minimal project for STM32 microcontroller for CMSIS programming. We are going to be using the Nucleo board, the same one we used in the previous videos. And if you haven't watched the previous videos, it would be a good idea to go through those, because we're not gonna do any setup over here anymore. So I will assume you will know how to set up an Eclipse and MCU plugin and all the other stuff we've done before. We are going to be using the microcontroller on the board we're going to be using is this one. So feel free to get any data sheets you need. We're gonna use STM32Cube, not to generate the project itself, but we will use it to get a linker file and get some startup files as well. We are using the GNU MCU Eclipse plugin, which has been recently renamed. So make sure you have that one installed. We are using the GNU ARM compiler as well, so feel free to get one over here. And we are also using the J-Link software interface. So you will need the J-Link drivers. And the last thing, as we've done in our previous videos, we're gonna convert our onboard ST-Link to a J-Link interface. Again, if you don't know how to do any of those, please watch the previous videos. They describe everything. Okay, so let's open our Eclipse and go to File, New Project, C and C++, and let's make it a C project. Let's call it minimal, and we're gonna base it off of the Hello World ARM Cortex-M template. Okay, next. As we've said before, we need to choose the correct processor core. So let's have a look at, let's go to our browser and have a look at the device. We are using this device, which is Cortex-M3, so that's what we want to set in our project. So let's choose that. All of those, the clock, the flash and RAM size, we don't need. It doesn't matter what they are going to be set as, and all of those are fine as default as well. Okay, let's go next. Those settings are fine as well, and that's fine as well. That's where our toolchain is. Make sure yours is set up correctly as well. No. Okay, so that's the project generated for template, and the same as before, we're just gonna shift-click select, and delete it all, because we are going to make our own. Right. So what I'm going to do, I'm gonna right-click and create a few folders. So we will want to have folder for source. We will want to have folder for header files, and then let's make a project for any of the system files. And in the system files, I'll just do this in advance, we'll have include as well. We have source. We're gonna have a folder for our linker as well. So that's our basic structure. There's nothing in there yet. If we go to properties, let's just clean up the template settings. Again, you would know if you watched the previous videos. One thing to do first, let's go under our devices. Select the STM, whatever board you've got. I've got the STM32L152RE. Apply, switch to release, and apply as well. If you don't see any of those devices over here, you will have to click this button and refresh your device list and download any devices you need. Right, preprocessor, let's get rid of this, rid of that, rid of that. I'll go through it quickly since we've done it in the previous videos. Let's get rid of the old includes, which they don't point to anything at the moment. The original linker files we don't have, and we do not use standard start files. We need this as well. Libraries, we don't need that. Switch to debug and do the same thing. Ooh, okay. Let's leave the debug in and remove everything else. Okay. Let's clean the includes. And those. Linker file. Clean all linker files. And that. Sorry if that's too quick. This is the tedious bit. Right, what we want to do is put our current includes. So let's add our include folder. And let's add the include folder in our sys folder as well. Okay, so I'll shift select, copy those and paste them in the other includes. Release and paste them in here. Okay, apply. Okay, linker file. We don't have the linker file yet. Okay, let's close this for now. Right, so the next thing to do is if we come in here, minimize that. Let's go to STM32Cube. Let's generate a really basic project for our microcontroller so we can grab a linker file and any of the system files we would need. Okay. Let's wait a bit. Right. Series STM32L1. Line 152. That's the one. Let's find it over here. 152 RE. Okay, that should be the one. Okay, let's go project and settings. And let's put it on desktop. Let's call it dude. And you can choose SW4 or makefile, it wouldn't matter. I'll choose makefile. So that's that. Okay. And project and generate code. Okay, so we can close this. And we have our generated code here. We don't need the generated code. What we need is the linker file and the startup file. Let's copy. I'll do Command C, copy the linker file and paste it here. And if you open the linker file, if you one thing which is actually a license thing, if I go, you might think I might need to run the STM32Cube. I'll just grab the file. Let's go to my folder, developer, STM32. If you just download the STM32Cube libraries, so for the L1 series, as we've got here, you can go to drivers, all driver, sorry, not CMSIS device, is it here? Templates, GCC. Sorry, I'm just doing that quickly. You could go theoretically and grab the linker files from here. which would be 152xe flash, so probably this one. Let me copy this, and I'll show you just what the difference is. I'll paste it in here, and you can see there is a copyright and permissions of that you can use this file only with the True Studio, so we should not be really using that. So I'll remove this. If you look at the file which has been generated by STM32Cube, that file is pretty much usable. Doesn't have the restrictions of the previous file. Right, sorry, that was just a little side turn. So we've got our linker file, and let's go, sorry, here, and let's get our startup file as well. So I just copied it and pasted it in the sys source folder as well. So that's our startup file. I'll right click and rename, because we know that Eclipse is not happy with the extension of lowercase s, so we need to capitalize it. Right. Okay, and that's our startup file. Okay, so let's just go into our source folder and make a new source file, main.c. Okay, we don't need that, and it would be main void. Let's make it an infinite loop. Right, that's a basic main file. One thing, we have added the linker file. Let's add it into our configuration as well. So I'll go to settings for the project. Let's go to linker. Why still this here? Right. Wonder if it didn't save it or something. Let's browse for it. Okay, copy, switch to release, paste. Okay, so let's make sure we've done everything. I've done it so quickly, I guess. So that's release, debug. Okay, includes. Oh, this is the old includes as well. Oh. Alt preprocessor, oh dear. Okay. Oh, this is debug. Okay, let's put the debug back in. Debug, copy, paste, and paste. No, not yet. So we are in debug. We have all the preprocessors. Includes, we don't have the includes for some reason. Okay. Include and sys include. Shift select copy and paste it here and here. So we have includes here, here, here. We have linker. This is not ticked. Okay, apply. Not yet. If I switch to release. Okay, that's correct. Okay, so have we just done the release before? Possibly. Right, apply and close. Okay, right. This is not going to build, but let's go step by step through what we need to do. If I click build over here. Right, you can actually see down here in the bottom, it says blah, 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 undefined reference to system init. The startup file provided by ST actually requires some other files, which we will copy in a second. But if you want it to have a really minimal project, you can actually write the system init function yourself, and that's actually being called before your main runs. So any initialization you need to do before main, you would do in there. So system, I'll show you just system init. Okay, that's the prototype. System init. Right, so we just put the function in, which doesn't do anything at all. I'll do that just to show you that it does build. If you try to start writing code like this, it's probably not going to run properly. We haven't, the system init normally does set the interrupt vector and all the stuff like that. Again, feel free to explore. This is theoretically the most minimal project you can have. If you do the system init correctly, then you can start from here. We're not gonna do that because that's too much in depth, and maybe some next time. So I'll get rid of this. I just wanted to show you how you can actually get it built and start working on it. So let's get rid of the system inits. Build again. And say, okay, so we have our previous error. We have undefined reference to system init. Just actually show you that if you open the startup file, you will see that this is the code that gets called when the processor first starts. Okay, and reset handler, which goes to loop copy data init, which goes here, which branches into here, and see over here you have branch to the system init, which doesn't exist, and you will see that your main is actually there as well. Right. Okay, let's go to the generated stuff and have a look at drivers, CMSIS, include, not this one, device, include. Right. Over here you can see there is a system STM32L1 file. So let's just copy that and put it into the system include folder. And if you open it up, you can see we've got, not here, it's a function prototype for our system init, the one we need. So we need to grab the C file as well, which would be hopefully here. Okay, let's put it in there. So that implements the system init over here. So let's try to build. Right, and you can see we've got another error, and it says, oh, STM32L1 blah blah H, no such file. Okay, so let's get this one as well. Right, that would be drivers, CMSIS include, I believe. Let's make it smaller. Right, and we need STM32L1XX. oh, that's actually not in this folder. That's in the device include folder, STL1XX. Okay, copy. Sorry, I'm making this step by step, so you can actually, if you wanted to, at any time you do it yourself. This is how, if I don't know something, that's how I would do it. I go step by step and see what the errors are and fix it as I go. So we've put in this file, let's build it. And to scroll to the top, you can see error, please select the first target, blah, blah. If I double click that, see, it will take us to STM32 into that header file. And it says select the target device. And if you remember from the previous videos, that's actually what we had to do before as well. and our device is STM32L152RE. So that one. So we need to define it in our project settings. So let me go to properties and preprocessor, and let's copy it everywhere. So preprocessor here, there, here. Let's apply just to make sure. Release, and let's paste it into our own release build as well. Apply. Okay. Right, so let's build again. And it goes, STM32L152XE. So that's another file we can grab from here. 152XE, is that the correct one? I think so. Let's put it into include. 152XE, 152XE, okay. It's built, and now we need core CM3.h. Okay, and that would be from the CMSIS folder, I believe. CM3. Okay. Well, then next time you know what files you need already, you can just copy it all at once. This I thought it was just more interesting. Okay. Okay, so it looks like we're gonna be missing those two as well. So CMINST and CMFunc. So let's copy those and put them in here. And build, and CMSIS GCC. Okay, copy that one, put it in here. Right, we have built. Woohoo! This still shows errors, but we know if we go and rebuild the index. Well, that was quick. If I go in here, that disappears. And that disappears. So let's close others. Right. So this is our basic project, just for using with the CMSIS libraries, which built, and it should work fine. We have nicked a lot of files for initializing from the STM Cube generated project. Right. So just to prove the point that the thing is working, we are going to flash we are going to turn on the LED on the board. Just have a look, make sure this is running. Okay, I have this, that's the video of the board. It's not this LED, there is another LED I think which is in here, which is green, and we will make that one to turn on. Okay. Right, just a second. Right, so what we'll have to do now is actually go to the datasheet, because we actually have set up our project, and what we need to do is to have a look at actually what we need to do in order to toggle a GPIO pin. So first and the most simple thing, we are not going to configure any system clock or anything. We'll just go with a default, just for the simplicity at the moment. We might do in later videos. But let's go to reset and clock control register. And if you look through those, we have peripheral clock enable register, quite a few of those actually. So if you click on here, you will see this is a clock enable register for all of the GPIOs over here. So that's the one we need. So RCC, H, and B, right. So, right, sorry, our LED, if you watched the previous video, or you can actually consult the datasheet for your dev board, is on GPIO A pin 5. So what we want to enable GPIO A, and what we will try to do, we'll try to set a pin 5 to be an output, and then set it high. Right. So let's enable clock for GPIO A. what was the resist? RCC AHB. Oh, okay, we have to include the header file. Sorry, system includes, and we want to include STM32L1XX. Okay. Here we go. AHB ENR. That's the one, isn't it? HB ENR. Oh. Okay. And we need to set bit 0. If we have a look in here, you can see 0 port clock is disabled, 1 port clock is enabled. So we want to set the bit 0 to enable the clock on GPIO. So people prefer different things, but I'll go like this. So we have unsigned int shifted by 0 positions. So basically a first bit or bit 0, and that would actually be enable GPIO A clock. Oops. Okay, let's see if that builds. It should build fine. Right. So theoretically, we have enabled the GPIO A clock. The next thing we want to do is let's have a look at the GPIO registers and GPIO port mode. Specify how is the pin or port set up. So you see this is most of registers are gonna be zeros by default, which makes them all inputs. And we want to make it a general purpose output mode. So again, we want to have to set it to 01. And our pin is GPIO A port pin 5. So that's 0, 1, 2, 3, 4, 5 right here. So let's set this one up to hex 01. Okay, so let's call this a make GPIO A pin 5 and output. Right, I go GPIO A. Motor. You can see that's the GPIO A motor. That's the register. And oops, let's set it this way. So if you look in here, we want to set it to hex 01. So let's put it in there, and we want to shift it to pin 5, and it's by 2 bits. So let's do it like so. Okay, that builds as well. And the last thing is we actually want to set the pin high. Okay, set GPIO A pin 5. And if we look at the data sheet, it would be port output data register. Right, ODR. So again, we want to have pin 5, and we want to set it to 1. Okay, so GPIO ODR, GPIO A, ODR. Okay, and I'll do the same thing. So it's 1 bit. shifted by 5, and that theoretically should lit the LED. Okay. Right, we haven't set the debug configuration yet, so let's do it. We were building as debug, which is fine. So let's go to debug configuration, double click the Sega J-Link, and it will create the debug configuration for us. This is set correctly to our device, and I'll put it in the shared file. And I'll go debug. Okay. What I might do as well, I go peripherals, and let's make sure that things are actually happening. RCC, let's find RCC. That's here. And let's watch GPIO as well. GPIO-A. Okay. Right, and we're gonna be fiddling with the AHB, which is that. Let's open that. Right, if I step through it, okay, let's step here, and you can see actually we have enabled the GPIO-A clock. Next step. Oh. Sorry, motor. Okay, you can see motor 5, which is our pin 5, is set to hex 1, which is correct as well. And oh, let's let me bring the. Oh, sorry. Let me bring the video in here as well. So we can watch it live. Right, so I'll step through the last step as well, and hopefully step over. Right, well, we are in an infinite loop over here, so this is going crazy, but you can see the green LED is on, which is good. So I actually managed to set the GPIO pin, or turn the LED on. Okay, let's turn this off. Let me actually show you one more thing. If you look at remember we were talking about the system, the build was complaining that we didn't have a system init function. If you look at this file, there is also system core clock update function. Let's copy it, and if I go here, there is a system core clock variable, which is somewhere in, not here, where is it? Oh, system core clock, which is basically a variable which will have information about your system clock in it. And this function does update the value of it. So let's go in here. I'm gonna call it here, and where was this is the variable. I'm gonna grab this, I'm gonna check it on the expression over here, and okay, let's close those, and let's run it again. Right, we have stopped. This is the number which has been set to the variable by default. If I do the first step, you can see it actually updated the variable based on what the real clock is at the moment on the device. Actually, if we go to RCC, is it control register, you can see we are running the MSI internal clock over here. Okay, well, I hope that you liked the video, and well, I might try to do more videos, maybe as setting up an interrupt on SysTick and stuff like that. So I'll see you later.